You, you've already heard about the problems of antibiotic resistance from two of our previous speakers. And by now, you must be thinking of what Alanis Morissette said, how do I get off these antibiotics? You'll have to wait 10 minutes for that, because I will be talking about antibiotics and the need for new drugs. The solutions we'll present are from a talented group of organisms, which are the Actinobacteria. And they're talented not only because they offer solutions to this problem, but because they span, as I'll talk to you about, medicine or pharmaceuticals and agriculture, but also because they offer opportunities in the short and the long term. So what are these Actinobacteria? They're a group of filamentous organisms. So they are bacteria that think they are fungi, in that they produce a range of interesting structures, and they are present everywhere. If you pick up a pinch of soil, there'll be at least 1 million of these bacteria in the soil. They give soil its perfume. If you smell rain, that is a compound geosmin produced by these microbes. So they are present in a lot of different places. They have proven talent. I've listed 5 antibiotics or metabolites that are produced by these Actinobacteria, starting from ivermectin, which is used in animal husbandry to keep livestock clean of insects. Adriamycin used still as an anti-tumor compound. Erythromycin, which, as we know, has been around for the past 40 years and still works. They also produce molecules that inhibit drug resistance, like clavulanic acid. And if you ever have to have an organ transplantation, you'll thank actinomycetes for producing rapamycin, which prevent organ rejection. So what we are looking for is not only one class of compound, but a number of different classes of compounds, because we know the problems of resistance. And so the discovery hypothesis is that if you want to get new actinobacterial strains, you want them because they'll have new biosynthetic pathways and therefore will produce new chemical structures and which have novel functions. So where do you get these new microbes? People have been looking at soils for the past 60 years. They've been going to deserts and forests. But we decided, let's look at something a little bit different, a new niche. And what we decided to look at are things that are living inside healthy plants. And what you can see here is we've tagged one of these strains so that we can show you that they actually reside in plants. These are, for example, in wheat roots, and what you can see is an abundance of these microbes living quite happily inside healthy plants. It also tells us that they produce molecules that are possibly fairly non-toxic because they're living inside a healthy tissue. So what we then did was we started looking for techniques that could give us large numbers of novel compounds. So we started with wheat, and for example, in wheat, you get a number of different genera. What was surprising was that of the 120 odd cultures we first isolated, at least 27% were novel, even though many of these were streptomyces, which is good because these are the guys that produce a lot of new molecules. Moving on to rice, which grows in Yanco in New South Wales, got plants from there, and what we found was certain plants have different populations. In this case, we got Microbial, which also means that different plant types might give us new organisms. We then said these plants grow for one season. Let's look at plants that have been around for 50 or 100 years. So we looked at native plants, eucalypts. And what we found was something even more interesting in that we obviously got a lot more strains. These plants have acquired these strains over the years. And we get genera that are listed up there that are not very commonly found in soil. And again, you can see the novelty is very high. So what do we do with this novelty? How do we discover new molecules? We need to get a technique which will give us an answer very quickly. So we've looked at information-rich screening, something which in 10 minutes, this is an HPLC profile. In 10 minutes, it'll give you an answer of what the molecule is, depending on when it comes out from the column. And if you look at the ultraviolet scan, that gives you an indication of the molecules that are in that peak. And you can do this for all the peaks, and then you might say, hey, we haven't seen this chemical structure at that time, and therefore these compounds are possibly novel. And what we do find is that the hit rate compared to soil microbes is about 5 to 6 times higher. And therefore, we do have a collection of strains that are producing novel molecules. We have isolated the first broad spectrum antibiotic, and we have candidates that need to be characterized. I'll move on to another talented approach that these microbes offer, and that is we know they produce a vast array of molecules that have interesting functions, and they're present in plants. So what are they actually doing in plants? Can we exploit these functions? And as a biotechnologist, we're always looking for new opportunities. So we said, how can you increase crop yields? One of the biggest problems in agriculture is fungal root pathogens. And we worked on this for about 5 years. And what we did find were these microbes, when added back to the seed and grown in the field, can not only promote plant growth in cereals, but they can control diseases like Pythium, Tacol, and Rhizoctonia. And we've conducted field trials for about 5 years, and we do find in disease soils grain yield increases of 10 to 15%. So these microbes do work in plants and can be used in the field to control diseases and get grain yields in a very sustainable manner. So it helps to reduce harmful chemicals and fertilizers. So the opportunity we have, again, as I said, we have strains that we know produce new molecules. We have one already. The opportunity is to join us in getting some more of these molecules. And again, as part of the mining boom, we can mine these for other new drug candidates, drugs that can be used in drug transformations, and in agriculture and the environment, new inoculants for increased crop yields. And we've also got some interesting work going on in nutrient uptake in legumes. So I'll stop there, and thank you.